So welcome again to this another amazing session of everyday mathematics. And today we move forward to the quarterfinals of the MIT 2023 Integration B. This happens to be the last session on this topic of logarithm because there was no question in the semi and the finals. Or the MIT 2023 Integration B that had logarithm in them. So the question today is just one question, and it was from the quarterfinals, number 2, and was the first question, which was the integral of x to the power minus log x from the square root of e to infinity. So we're going to begin attacking this question by, first of all, supposing that u be equal to log x, such that du dx is 1 over x. And also from that expression, we know that e to the power u will be equal to x. And therefore, combining these two expressions, e to the power u du is equals to dx. And now transforming the limits, when x is equals to square root of e, which is the lower bound here, u is definitely log of square root of e, therefore taking half on the other side, log the base e of e will be equal to 1, and therefore u is half. And when x is infinity, u still remains infinity. And so transforming that integral, we get the integral of x to the power minus log x is from square root of e to infinity is the same as the integral of e to the power u to the power negative u times e to the power u from half to infinity. So just transforming that further, we get that that's the same as the integral of e to the power negative u squared plus u from half to infinity. We can transform this power here by, first of all, using this expression where u minus half squared is the same as u squared minus u plus a quarter, and therefore negative u squared plus u from this power here is the same as negative of this, negative of u squared minus u plus a quarter. And since this negative, we have an extra negative a quarter here, we can cancel that out by adding another quarter. Therefore, the expression negative u squared plus u is the same as negative into brackets u minus half squared plus a quarter. So employing this expression back into the integral, we have an extra power here, which is e to the power quarter, which we can pull out as a constant. And now we are left with an integral of e to the power negative u minus half, all that in squared, from half to infinity. We can also do another transformation where we let this complicated power here to be equal to just y. So let y is equals to u minus half, and therefore dy du is just 1, and therefore dy is equals to du. Then transforming the limits, when u is equals to a half, therefore y is equals to half minus half, therefore y is 0. When u is infinity, y would still remain infinity. And so we go ahead and look at our integral transforming as follows. So we have e to the power a quarter times the integral that we saw previously, the same as e to the power quarter, integral of e to the power negative y squared from 0 to infinity, which is the same as half of the integral from negative infinity to infinity of e to the power y squared. Now we realize that this integral here surrounded by the blue rectangle is a Gaussian integral, and that is a popular integral that is equal to square root of infinity. Therefore, our answer is e to the power quarter times square root of 5 over 2. And that is our final answer. This is our final answer. Thank you. So we're going to try and solve the question with Python. So we're using Jupyter Notebook. The first thing we'd want to do is we'd want to import SymPy as SMP. Let me see if we can import NumPy as NP. Import SciPy as SP. We'll want to import matplotlib dot pyplot as plot from SciPy dot integrate. We want to import code SciPy dot integrate. I would want to import cumulative that trapezoid. And let's see whether we can import that and then define X as a symbol, SMP dot symbols X. And then we want to define it as true. And then the next thing we want to define is the function, which is X to the power negative log. I think it's an SMP function. X, let's see what F looks like. Good. And so the next thing is we want to integrate F with respect to X, starting from SMP dot log. I think it's a square root first. Square root of SMP. SC SMP exponential of 1, that is E. And then the last limit is infinity. And how you do that in Python is just 2 zeros. So let's see. So, well, it leaves us hanging, but it gives us the expression that we had wanted to integrate, but we don't have any answer. So that's where Python leaves us. But if we try to go ahead and use Wolfram Alpha, the interesting bit is I think it will give us a correct answer. So what we'll do is we'll select that, and our lower limit is square root of E, upper limit is infinity, and we want to integrate from that to that. Let's see. Yeah, it gives us the answer we had wanted. So Wolfram Alpha, always concise and to the point. Yeah, thank you so much. That's where we stop.